Hello everyone, welcome back to my channel. Today let's go over a premium medium question that I just solved on my own. So I'm actually really happy about this because I struggled with this so many times and there was just one edge case that kept failing for me, and I was finally able to print enough things and debug it and figure it out. So again, I'm really happy that I solved this without any help. So let me show you how I did it. Basically, the ask is pretty simple. Return a Boolean based on from the top left to the bottom right if there's any path that has the same number of zeros and ones. So this is a dynamic programming question, so I'm going to do this recursively. So let's go ahead and create a 0 count and a 1 count. Because there's nothing there, we're going to start at 0, 0 and define a recursive function, which is just going to start at the x and the y, and then the 0 count and the 1 count, right? And then we're going to have a flag that's going to be true or false if there's any path that has an equal number. So we're going to return that Boolean at the end. So this is the row and the column. And then we're going to have the 0 count and the 1 count. So first of all, so we can either go right or down, right? We can't go diagonal. So at each path, we have two choices that we have to stage for the future, and we have to commit to that choice. So first, let's do our boundary check. So if row is bigger than or equal to length of grid, or column is bigger than or equal to length of grid 0, or row is less than 0, or column is less than 0. So we're out of bounds, whatever direction it is, then we can just return. Cool. So now that we don't return, what do we do? So this is really important because now we have to, and this is where I messed up originally, we have to check if grid of row or column is equal to a 0, then you increment the 0 count, right? Otherwise, if it's going to be, the value is supposed to be 1, then we print 1 count, right? And then after doing this, obviously, so we've seen the current row or the current cell. So now we have to ask if row is equal to length of grid minus 1. So we're checking if we're in the bottom left or the bottom right, or column is equal to length of grid 0 minus 1. Then we have to ask if 0 count is equal to 1 count at the time, and we're at the bottom left. That means we found a valid path. So we set the flag to true, and then we break out. Otherwise, we do a recursive call on row plus 1. It says right here, and column, that's 0 count and 1 count. And then we also try, so this is down, this is going right, row plus row, column plus 1, and 0 count and 1 count. Okay, so let's run this. Or anything's out of bounds. So let's go ahead and print this so you can see. And this is the part where I messed up in the beginning. I put this in the wrong order, so I put this below here. But basically, after doing a lot of debugging, I figured that out, that you just want these to match up, right? So at 0, 0, if we're looking at this grid, we have 0 zeros and 1, 1. And then exploring down, we have another 0, so another equal. 2, 0, that's 1. 2, 1 is going to be, now we've seen a total of 2 zeros and 2 ones, right? So you just want to make sure that lines up for each case. And at the end, if we submit it, this is going to be a little bit slow, which is something else I ran into. So we need to throw an @cache on this so we can memoize the results. And there you go, passes all test cases. So again, I'm really proud of solving this on my own. I usually am not very good with dynamic programming, so it's a big deal for me. So yeah, pretty proud of it. And thank you for watching, and stay tuned for more.